Today, you will be completing the 3-2 Day 2 notes and submitting the entire filled out note sheet to my Schoology page. Now, we will do some of this together, but there is the expectation that you will try your hardest to complete the problems we do not do together on your own. Obviously, there is a key posted as always, but I do ask that you're doing your best to understand the material as you will be quizzed on this material when we return. Now, there is a warm-up in today's notes that goes over what we learned yesterday, so at this time, please pause the notes, complete the warm-up, and when you're finished, please start playing the video again. Here are the answers to the warm-up. Usually students do very well with questions 1 and 2 because that's just the rewriting that we talked about yesterday. And for the most part, questions A through E tend to go pretty well as well, just based on our notes from yesterday if you use those. The question I always get asked about is on part F. So I want to talk about part F and discuss what's happening here. Now, let me just get rid of some of my notes here, and then I'll walk you through this. On part F, if you do... I don't think that was the same color. Let me go that one. If you do the circle of life, you're going to see that 16 to the x power equals 64. Now, this is really tricky because I'm thinking 16 to the first power is 16, but 16 to the second power is way too large. So I know that this number is between 1 and 2, but how would I get that number? Well, what I like to do is think about what you did last year in Algebra 2 with trig. Get the same base. I know that 16 is really 4 to the second power, and 64 is 4 to the third power. So I need to think about what could I fill in for x to make these two sides equal to each other. So I want to set these two exponents equal, and when I solve, I get an x value of 3/2. So today, we're going to be looking at graphing log functions. I will do problem number 4 with you, and then you will get a problem to try on your own. For log functions, I am going to ask that you know how to do this in your calculator, and you do not need to know this by hand. So if you guys could please go to your calculators, and let's talk about how to graph a log function. Now, if you go to your y equals, and we want to type in log base 2 of x, there are 2 different ways you can do this. Some of you are very lucky, and if you go to the math button on your calculator, you will see all the way down, there is a button that says log base. If you have this button, hit enter, and it allows you to type in any base that you want, and then anything inside of the parentheses. Now, if you don't have this button, your second option is to do what we call the change of base formula, which actually everyone's going to learn and need to know for the quiz. This involves taking the log, and log base 2 of x is actually equivalent to the log of the argument, remember we call this the argument, over the log of the base. We'll discuss this more, but for now, you can use that. So in your calculator, you would just type in log x divided by log 2, and you would get the same graph as everybody else. So either way you type this in, what I would like for you guys to now do is go to your graph, and let's see what this looks like. Now, if you still have the same window from the last time we did the problem, make sure you go to Zoom and then do a Zoom standard window, Zoom 6, and then you should see the same graph that I'm seeing. Now, as you guys are graphing this, you will notice some similarities to the exponential function. But remember, these are inverses of each other, which means that if you had all the ordered pairs of an exponential function and you switch the x and y, you are now looking at its inverse function, the log function. This means that what was once the domain will now be your range. What was once the range will now be your domain. What was once a horizontal asymptote will now be a vertical asymptote. So let's graph this. If you go to your table, you will see in your table that there are error messages for all the values of 0 and smaller. There's a reason for this. Last year, you should have learned that the argument always has to be greater than 0. Any value that makes that argument equal to 0 or less than 0 does not work in our domain. So with that being said, we need to look at values that don't make it 0. Starting with 1, we have a value of 0 there. Starting at 2, we have a 1. And then we can scroll down in our table just to see some other values. And you'll notice that there are other nice values, but we do have a lot of decimals in here too. We have 4, 2, and then we have 8, 3. So what I'm going to do is I'm going to look at my graph, and I am going to get this sketched. 1, 0, 2, 1, 4, 2, and then 8, 3. Now, if you look at what's happening towards the y-axis, you may say, oh, look, it stops. But if you hit trace and hit 0.5, you'll notice that at 0.5, it's actually at -1. If I hit 0.4, notice that it goes even lower at -1.3. And if I hit 0.1, so think about how close I am to the y-axis, I'm getting that it's at -3. If I hit 0.01, notice that it's at -6, somewhere down here, maybe a little bit further down, but you get the idea. If I hit 0.0001, notice that this keeps going lower and lower and lower, because what you are seeing, even though the graphing calculator is not showing it very well, is an asymptote. But this, my friends, is not a horizontal asymptote, it's vertical. So as a result, when we have to go to asymptote, now it'll be a vertical asymptote. So instead of being y equals, it'll be x equals, and notice that that would be a value of 0. Now, to answer the remaining questions, just like before, when we had to look at the asymptote to determine the range, we now are going to have to look at the asymptote to determine the domain. Because what you'll see is that all of our x values are going to have to be, in this case, larger than 0. So we're going to say from 0 to infinity. Now our range is going to actually be all real numbers. So keep in mind that because this is in the inverse of an exponential function, what was once the domain is now the range. What was once the range is now going to be the domain. We're going to see that these flip. Our x-intercept we can see is 1, 0, but notice this time we have no y-intercept because there's a vertical asymptote there. Now, as you look left to right, this is an increasing function. And this is a lot like exponential growth and decay, where if your base number down here is greater than 1, you'll see that the function increases left to right. Now, final thing, and a little tricky, is talking about the end behavior of this graph. What function was this, f of x? So normally we would look at as x goes to -infinity, and we would look at as x goes to +infinity. But here's the issue with this problem. If you look, x can't go to -infinity. In fact, it gets stopped at 0. So if I ask you to look at the left end, you can't look at as x goes to -infinity. You have to look at as x goes to 0 from the right. Do you guys remember from first semester when we talked about limits that if there's a plus sign, it means from the right? And then if there's a minus sign, it means from the left. Now, since we're on the right-hand side of this asymptote, we would consider the from the right scenario. So as we approach 0 from the right, notice we are going to -infinity. As we approach infinity, which means as the graph goes to the right, we are also going to infinity. So unlike horizontal problems, where we look at this, and I'm sorry, horizontal, unlike exponential functions where we look at one end and it approaches the asymptote, this happens here as well. But notice that since we're talking about what's happening to the y values and it's not flattening out like we see in exponential functions, you'll actually see both of these ends going to infinity or -infinity. So you can try number 5 at this time. Obviously, check your answer with the key, but you will need to complete this when you submit your notes. And we are going to move onward to the final topic I wanted to look at regarding this topic. So you will also be expected to do transformations without the use of a calculator. So with that being said, if I give you a log function and I say state the transformations, if you look at the parent function given, notice both of these have a base of 4, so that's not a transformation. Just like we've done in the past, we're going to circle each transformation and state what's happening. A negative in front, remember, means reflection. Now, because it's on the outside, it is the y values, but remember, over the x-axis. I see a 2 on the inside, so I know that that's a horizontal transformation, but remember, this is not what you think. I think it would be a stretch by 2, but it's actually a shrink by half. And then finally, this -4 is on the outside, so that is a vertical shift, exactly as you would think. I would think it'd be down 4, and that's exactly what we see. So you guys can complete number 7 at this time. And then the final question I wanted to do with you, and then the remaining questions are for you for homework, is this question number 8. It says, without using a calculator, answer these questions. So first thing, stating the transformations. This isn't bad. I see that this has a +5, so keep in mind that that would be that horizontal shift. I would think to the right, but actually to the left 5 units. Now, when you're asked to state the domain, remember that I said that the argument always has to be greater than 0. So if you are ever asked to state the domain of any log function, you're going to take what's in the parentheses and say that it has to be greater than 0, and then solve for x. This right here represents the domain of our function. The number that you get right here is actually going to be the asymptote value, because think about that is when it's going to equal 0. Now, if I ask you to state the end behavior without a calculator, you're going to think about that this right here is our vertical asymptote. So this is -5. And if we're looking at a log function, think about the base of this log function is 4. That means it's going to increase left to right. So somewhere we're going to cross the x-axis, and we're going to see that it's going to increase. But then as we get to the asymptote, it's going to obviously approach that asymptote. So if I'm stating the end behavior here, I would say the limit on h of x as x goes to, now can't say -infinity, we're going to say -5 from the right. Notice that in this situation, it's going to -infinity. Then I have the limit h of x as x goes to infinity, and note that the function increases, so it will also go to infinity. So you have questions 9 and 10 to complete, as well as the problems that I skipped over, and then once you're finished with that, you could submit this to Schoology. Hope you're doing